From the Virginia Audio Collective at WTJU 91.1 FM and Brown College at the University of Virginia, this is Symposia.
Welcome to Symposia. I'm Sage Tanguay. In October 2022, physicist and writer Alan Lightman visited Brown College. Here to introduce Alan Lightman's lecture is Brown College principal Dr. Jim Coan and his daughter Veronica.
Who is Alan Lightman?
I know, that's what I said. Who is Alan Lightman?
Alan Lightman is a professor of physics and creative writing at MIT, which is the Massachusetts Institute of Technology. And he's really well known both for his scientific work and for his novels and poetry and numerous essays that you can find in places like the Atlantic Monthly, the New York Times, and the Marginalian.
And what did he write about?
Well, when he was early in his career, he wrote about some theoretical problems in physics. Later on, he began writing for the public about not only what he was learning in science, but also about what it sort of means to be a human person with the ability to think and know about the universe at the same time as knowing how the universe works. What do you think of that?
Cool.
And you know what he did?
Of course I don't. Why did he come to Brown College?
So Alan Lightman came to Brown College because of a course that was taught at Monroe Hill House on the writings of Alan Lightman. And then we were able to actually bring Alan Lightman to Brown to meet with students and talk with them about what, they had thought of his books or why he wrote them. And then we had a meeting in the Rotunda, in the dome room. He gave a speech about his career and his point of view on what is sacred for a person who doesn't necessarily believe in God, but who believes that the universe is so mysterious that just reflecting on how amazing it is can fill a person with a feeling of awe. Let's take a listen.
I've always been interested in both the sciences and humanities and the arts, and even have found a creative tension between those different disciplines, but it's been a constant rumbling in my gut. In childhood, I wrote dozens of poems. In my poetry, I expressed my questions about death, loneliness, my admiration for a plum-colored sky, my unrequited love for certain girls. There are overdue books of poetry that littered my second-floor bedroom, and I understood even at that age that words could be mesmerizing, the movement of words. Words could be sudden like jolt, or words could be slow like meandering. Words could be sharp or smooth, prickly to the touch, cool. They could be blaring like a trumpet call, and almost by magic, words could create scenes and emotions. And I remember that when my grandfather died, I was about 9 years old. About a month after he died, I wrote a poem about how I was feeling about that, and I read it to my grandmother. And she cradled my arm in her hands. She cradled my face in her hands and then started crying all over again after listening to my poem. And I wondered how black marks on a white sheet of paper could create that kind of emotion and force. Between poems, I did scientific experiments. I built a little homemade laboratory in a large closet of my bedroom, and there I hoarded wires of various thicknesses, capacitors, transistors, test tubes, beautiful glass flasks, dangerous chemicals, and I delighted in my equipment. I loved to build things. Around the age of 13, I built a remote control device that could turn on the lights in any room of the house from any other room, which awed my 3 younger brothers. After seeing the Frankenstein movie, I built a spark-generating coil. I used a fishing rod to wind about 2 miles of wire around a metal core. In some of my scientific investigations, I had a partner named John, who was a high school friend. He was a year older than me. John did not share my interest in poetry and the higher arts. John thought all of that was a waste of time. He was all practicality. As it turned out, he was a genius with his hands, much better than I. He would patch together odds and ends from around the house and build things. I would be his assistant. He never saved the directions that came with new parts. He never made wiring diagrams, but he had the magic touch, and he would build things that they worked. They were not pretty, but they worked, usually better than anything that I built. It was with my rocket project that my scientific and artistic proclivities collided. Ever since the launch of Sputnik in 1957, I was around 9 years old at the time, I was transfixed by the idea of building a rocket of my own. And I imagined the blast off, the plume of smoke, the trajectory in the sky as sunlight reflected off the rocket. By the age of 14, I was mixing my own rocket fuels. A fuel that burned too quickly would explode like a bomb, and a fuel that burned too slowly would simmer like a barbecue grill. I think you probably have barbecue here. We had plenty of it in Memphis, the barbecue capital of the world, we like to think. Anyway, for the ignition, I used the flash bulb of a Brownie camera. How many of you remember Brownie cameras? The older people in the audience. And you remember it was a one-shot deal. It would go off and it was done. It would make a lot of heat. So putting the bulb of a Brownie camera in the tail end of the rocket in the fuel chamber was a good way to ignite the fuel. And I could set off the bulb with wires that trailed from the tail of the rocket to my command bunker a couple of 100 feet away. The body of the rocket I built from an aluminum tube. It had a red nose cone and black tail fins, and it was just gorgeous, this rocket that I built. Well, I invited my awed younger brothers and a number of friends from the neighborhood to attend the launch of the rocket, which occurred one Sunday at dawn at the Ridgeway Golf Course in Memphis. John did not attend. He didn't see anything useful about these rockets, but even so, I had a good audience. There were a lot of kids from the neighborhood who came, and I had calculated from weight and thrust how high the rocket should rise in space. I calculated it should go up about a half a mile, and because of that, some of the boys brought binoculars. Well, from my control center, I called out the countdown. I closed the switch, ignition, the rocket blasted off beautifully, but after rising only a couple 100 feet, it did this sickening swerve. It spun out of control and crashed. The tail fins had come off, and I suddenly realized that instead of riveting on the tail fins, as I should have done, I considered rivets too ugly. So I had just glued the tail fins on, and evidently I had sacrificed reality for aesthetics. And later on I learned that I was not the first scientist in history for whom beauty had ultimately succumbed to reality. For centuries, astronomers believed that the orbits of planets are circles because the circle is the most perfect geometric shape. And it wasn't until the 16th century and 17th centuries that we realized that the orbits are ellipses, not circles, from observations. Another equally beautiful idea that turned out to be wrong was the idea dating from the 1930s that the phenomena of nature should be identical if right and left hands are reversed, like looking at the mirror image of the thing. That's called parity conservation. And that beautiful idea was also proven wrong by experiments in the late 1950s. When my scientific projects went awry, I could always find certain fulfillment in mathematics. I loved mathematics just as I loved poetry and science, and I still love mathematics. When my teachers assigned homework, I would save my math problems for last, right before bedtime, like a dessert after a dutiful meal of history or Latin. And then I would devour my cake. In geometry, I loved the diagrams. I loved the relationships between angles and lines. In algebra, I loved the abstraction of letting X's and Y's stand for the number of pennies in a jar. And then solving equations, one logical step after another. I loved the purity of mathematics, the logic, the precision, the certainty. The humanities and arts were filled with uncertainties. Is it okay to steal in order to feed your family? What was the meaning of Picasso's Demoiselle d'Avignon? Why did Raskolnikov kill the old lady in Dostoevsky's Crime and Punishment? These questions are full of ambiguities and they don't have easy answers. But in science and mathematics, you don't have to deal with those kinds of ambiguities. You're guaranteed an answer as clean and as crisp as a new $20 bill. And when you find that answer, you're right. You're unquestionably right. The area of a circle is pi r squared, period. Mathematics also contrasted strongly with the contradictions of people. I'm talking in the past tense now because I'm going back to my childhood. The world of people had no certainty or logic. People confused me. My mother sometimes said cruel things to us boys, even though we knew that she loved us. My Aunt Jean continued to drive recklessly in her little MG sports car, even though everyone in the family told her that she would kill herself someday. How does one make sense of such actions and words? I've lived in several communities for many years, the community of scientists, the community of artists, and the community of humanists, and I have tentative answers to some of these questions. So that's what I'd like to tell you about this afternoon or tonight, whatever time it is. And I've learned a little bit about the different ways that these communities think about the world, their different approaches to truth. So since I'm a writer, most of my examples will come from the arts. Most of my examples from the arts will come from literature since I'm a writer. But I think that my comments apply to the arts in general. And the humanities come in here and there in the general sensibility. A big distinction that I have found between physicists and novelists, or between scientists and artists generally, is what I'll call the naming of things. And roughly speaking, the scientist tries to name things and the artist tries to avoid naming things. To name a thing, you've distilled it and purified it, you've put it in a box, and you've said what's in the box is a thing and what's not in the box is not the thing. For example, the word electron, which is a type of subatomic particle. As far as we know, all of the electrons in the universe are identical. There's only a single kind of electron, and to a modern physicist, the word electron means a particular equation. It has a name, but that's not relevant here. That equation summarizes everything that we know about electrons. Every slight deflection that an electron makes in an electric or magnetic field, the energies of electrons in atoms, the way that electrons and antiparticles can materialize out of energy, all of that can be predicted accurately to many decimal places by this equation. In a real sense, the word electron refers to that equation. It's called the Dirac equation. Every physical object in the universe, the scientist wants to be able to express with this kind of precision. It's a great comfort, a feeling of power, a sense of control to be able to name things in this precise way. The objects and the concepts that the novelist or the artist works with cannot be named. The novelist might use a word like love or fear, but those names don't really summarize or convey much to the reader. For one thing, there are 1,000 different kinds of love. There's a love that you feel for a mother who writes you every day your first summer at camp away from home. There's a love that you feel for a mother who slaps you when you come home from the prom drunk and then embraces you. There's the love for a man or woman that you've made love to. There's the love for a friend who calls you up after you've broken up from your spouse. And those are just a few examples of the many, many different kinds of love. But it's not just the different kinds of love that prevent the novelist from truly naming the thing. It's that the sensation of love must be shown by the actions of characters, not named but shown. And if it's shown, then each reader or viewer will experience it in a different way, will bring their own life experiences, their own adventures and misadventures with love. Love means one thing to one person and a different thing to another. Every electron is identical, but every love is different. The novelist doesn't want to try to eliminate these differences, doesn't want to try to clarify and distill the meaning of love so that there's only a single meaning like electron, because, first of all, no such distillation could occur. But more importantly, even an attempt at such a distillation would destroy the authenticity of reactions of readers, would destroy that delicate participatory creative act that happens when a good reader reads a good book. The reader is really creating the novel with the writer. And in a sense, a novel is not completed until it is read by a reader, and every reader completes the novel in a different way. And I would argue that it's the same when looking at a painting or listening to a symphony. I'll give another illustration of the difference between naming and not naming, and let me make an analogy between the scientific enterprise and expository writing. That might seem a little far-fetched, but expository writing, you're making an argument, you amass facts to support your argument, evidence, and you lead your reader through a logical path from the beginning to the end. Now, we all learn in high school, although I was never able to teach my daughters this, and we all should learn in high school that it's good form to begin in expository writing, to begin each paragraph with a topic sentence. Begin by telling your reader what she's going to learn in the paragraph and how to organize her thoughts. But in fiction writing, a topic sentence is fatal because the power of fiction is emotional and sensual. You want your reader to feel what you're saying, to be part of the scene, to be carried off into their own imagination. And every reader will travel differently depending on her own life experiences. And if you tell your reader right at the beginning, with the first sentence of the paragraph, how she's supposed to think about this experience, it totally cancels the trip. You're just, with a topic sentence, you're just not leaving room for your reader's imagination and their own creativity. I think the difference can be stated in terms of the body, that in expository writing, you want to go to your reader's brain, and in creative writing, you want to bypass the brain and go to your reader's heart or stomach. There's a pattern of thinking that's closely related to the tradition, to naming, and that's the tradition of framing problems in terms of questions and answers. And scientists usually work by finding problems that have definite answers. It might take a year to find the answer, it might take 10 years, but at any given moment, each scientist is working on a problem that he or she believes has a definite answer. And then we work by breaking that problem into smaller and smaller pieces, each which has a definite answer. For example, where in the living cell are the instructions located to produce a new creature? That's a well-posed problem. Another piece of the problem is, what is the molecule that has those instructions on it? Another piece of the problem would be, what is the arrangement of those molecules? And we scientists are taught from an early age of our apprenticeship not to waste time on questions that don't have definite answers. But the practitioners of the arts and humanities are less concerned with definite answers, because often definite answers don't exist. Ideas in a novel or a painting are complicated with the intrinsic ambiguity of human nature. Indeed, I think it's the contradictions and uncertainties of the human heart that make life interesting. They are why the characters in a good novel can be debated endlessly. They're why God held the apple in front of Eve and then forbade her to eat it. For scientists and humanists, there are many interesting questions without answers, such as, what is the nature of God? Or would we be happier if we lived to be 1,000 years old? Or what is the best form of government? In fact, for many artists and humanists, the question is more important than the answer. As the German poet Rainer Maria Rilke wrote a century ago, we should try to love the questions themselves, like locked rooms or like books written in a very foreign tongue. I love that comment from Rilke. It comes from his little book, Letters to a Young Poet. So I've come to learn that we need questions with answers, and we also need questions without answers, that both kinds of questions are part of being human. I wanted to say something now about the substantial common ground of the physicists and the novelists, or between the scientists and the artists or humanists. First, both seek beauty. Beauty is a thing that's hard to define, but we know it when we see it. My wife is a painter, and she talks about simplicity of design, unity, balance. You're probably less familiar with beauty in science. In fact, in my wonderful meeting with physics students today, one of the students asked me about beauty in science and how do you convey that. And I've had a marvelous time meeting the students here at University of Virginia, both last night and today. A very bright group of young people, so I congratulate everybody here for that. The Nobel Prize-winning physicist Steven Weinberg has a whole chapter in one of his books called Beautiful Theories, and one of the qualities that he associates with beauty in science is simplicity, the same word that my wife uses. For example, in Einstein's theory of gravity, and Professor Trendle mentioned Einstein a number of times, in fact, stole a lot of my talk, but that's okay. Einstein's theory of gravity starts off with just the idea that gravity is equivalent to acceleration. And from that one simple idea, the entire theory of gravity emerges with all of its complex mathematics. And of course, you've all seen paintings and heard musical compositions where you felt that not a single brushstroke could be changed or a single note. Let me turn to the concept of truth. The folklore is that novelists make up everything and scientists make up nothing. Both views are false. Creative imagination and inventiveness have always been hallmarks of good scientists, just as of good novelists. On the other hand, novelists must conform to a certain body of recognized truth about human nature. Einstein often emphasized the importance of what Professor Trendle called free play. It's probably a translation of the German. I call it free invention, which is really pretty much the same thing. And the great physicists believe that we cannot arrive at the truths of nature simply by observation and experiment, that we have to use the free invention of our mind. One of the best illustrations of Einstein's free invention or free play was his work on the theory of relativity, where he begins with this stunning postulate that a light moving past you will move past you at the same speed whether you're running towards the light beam or away from it. That's like if you're running towards a car, it will come at you at the same speed as if you want to run away from the car. Just totally non-intuitive, totally violates common sense. But Einstein realized that our common sense could be in error when it comes to very, very fast speeds, like the speed of light. Of course, scientists can't make up everything when they're inventing new theories. You can't invent a theory of gravity where apples fall up instead of down when they come off trees. There's a lot of established knowledge of the world that the scientist has to concur with. But what are the facts that the novelist must concur with? And I would say that that's the large catalog of behavior and psychology of Homo sapiens, a catalog that we sometimes call human nature. And those are the facts of emotional truth that the novelist is bound by. And let me give you an example of what I'm talking about. Suppose a novelist has created a character about 40 years old, married with 2 children. We'll call him Gabriel. And Gabriel and his wife go to a Christmas party. They've left their children at a nearby town with a nanny. So let's call Gabriel's wife Greta. When Gabriel first arrived at the Christmas party, he was afraid that he had insulted the housekeeper's daughter. And a little bit later, he's going to make an after-dinner speech, and he worries about how that speech will be received. So he's not completely sure of himself, this Gabriel. Well, the party ends, and Gabriel and Greta begin walking to a hotel where they've reserved a room. Greta has been very quiet during the evening, but Gabriel looks over at her and admires her all over again, wonders whether she still feels the love for him that they had when they were first married. He wonders whether she physically desires him as she did when they were first married. So they get to their hotel room, and they walk up a curving stairway up to their room. It's on the 3rd floor. The passageway is lit only by candlelight. You can see snowing coming outside the windows. They go into the room, and Gabriel is hoping that Greta will feel some attraction to him. But instead, she turns away from him and begins to cry. And he asks her what's wrong. And she says that a young man sang a sad song at the Christmas party, and it reminded her of another young man that she knew in her youth. Well, at this point, Gabriel begins to get a little bit worried, and he asks her he questions his wife about this young man of the distant past. Greta says that he was 17 years old, and he worked in the gasworks, and he had delicate brown eyes. They used to go walking together in the country. And Gabriel asked his wife, "Were you in love with this boy?" And she says, "We were great together at the time." And then she says that this boy died at age 17. And Gabriel asked her, what did he die of? And Greta says, "I think he died for me." Well, at this point, I'm asking you, some of you may know that this scene I've described is near the end of James Joyce's famous story, The Dead. And the question is, how will Joyce end the scene? What will Gabriel's reaction be to his wife's confession? Suppose that Gabriel shows no reaction at all. Well, we, with our life experiences, would know that that wouldn't ring true. We wouldn't believe that. Suppose Gabriel acts superior to this young man of the distant past. After all, he's only a boy, I'm a man, and he dismisses his wife's pain. Well, we wouldn't believe that reaction either, because we know that Gabriel is a somewhat insecure character. We knew that earlier in the story. So the ending that Joyce actually writes is this. Gabriel realizes that his wife has loved this young boy of the distant past more than she's ever loved him. And he also realizes that he's never loved any woman, including his wife, with the passion that she has just shown. And he looks over at her, listening to her breathing as she's fallen asleep now, looking at her as if he and she had never been husband and wife. This is an ending we believe. And we know that it's true even in fiction because it accords with our life experiences, with our knowledge of human nature, with our personal experience with life. It's an ending that causes us anguish, but a lot of great fiction does. Both the novelist and the scientist are seeking truth. For the novelist, truth in the world of the mind and the heart. For the physicist and the scientist, truth in the world of mass and force. In seeking truth, both the novelist and the physicist, or the artist and the scientist, both must invent in seeking truth. And both kinds of invention must be tested against experiment and experience. The tests in science are more final because a proposition can be definitively proven false. No matter how beautiful a theory is, it can be proven false. A novelist's characters or story cannot be proven definitively wrong, but they can ring untrue, they can ring false, and thus lose their power. And in this way, both the scientist and the artist are constantly testing their work against the accumulated life experience of the reader. Or I should say, the novelist is testing her fiction against the accumulated life experience of the reader. The scientist, of course, is testing his inventions against experiment. The scientists and artists that I've known have at least one more thing in common. They do what they do because they love it, and they can't imagine doing anything else. This is both a blessing and a burden, this compulsion. It's a blessing because the creative life is not given to all of us. I think we're all creative in some ways. It's a burden because when the call comes, it can be unrelenting and it can drown out the rest of life. This blessing and burden must be what Walt Whitman was referring to with his phrase, sweet hell, is the phrase he used when he realized that he was destined to be a poet. Never more shall I escape, he said. And this blessing and burden must also be why the astrophysicist Chandrasekhar kept writing and kept doing physics until he was in his 80s, why Einstein, once in his apartment, was found rocking the cradle of his son with one hand and writing equations with the other. I wanted to end with a few words about the mutual influence that scientists, artists, and humanists have on each other. And of course, I think that this is also in the spirit of Professor Trindle. But before I say a few words there, I want to add that it's important that in our colleges and universities, that there's value in having both different disciplines and having interdisciplinary courses. That each discipline has its own methodology, its own way of looking at the world, its own perspective, its own tools for thinking, and you want to give your students access to all of those different tools. You don't want to merge the disciplines. You want to keep those tools sharp. But also, there's much value in having interdisciplinary courses in addition to the individual disciplines, where students trained in particular disciplines like economics or history or physics can join other students trained in particular disciplines and see how their several disciplines are needed to solve certain problems, like climate change, which involves at a minimum the disciplines of chemistry, physics, biology, economics, sociology, and politics. Climate change is not only a scientific problem, it's a political, ethical, and sociological problem. Well, let me turn now for the very last part of my talk again to the mutual influence of the science, arts, and humanities. And I'll give some of these influences are direct, some of them indirect. I'll give a couple of examples. In formulating his theory of relativity, Einstein, as I said earlier, did not start from observations of nature and then generalize to a law or principle. That's called inductive reasoning, and that's the kind of reasoning that almost all scientists had before Einstein. Instead, Einstein started with an hypothesized principle, that is that all observers see a light ray with the same speed independent of their motion, and then he deduced the consequences of that principle. This is called deductive reasoning, and it's what I referred to earlier as free invention of the mind, and what Professor Trindle referred to as free play. For this kind of thinking, Einstein explicitly credited the Scottish philosopher David Hume. Hume argued that all knowledge of the world based on experience is much less certain than we think it is. We assume necessary causal connections between things when they aren't necessary. For example, suppose you go into a pool hall and you see a billiard ball strike a second ball, and the second ball begins moving when it was struck by the first ball. Well, you think logically, naturally, that there's a causal connection between these two events. But you don't know for sure that there couldn't be a small man hidden underneath the pool table who is watching the balls very carefully and kicks the second ball just at the moment that the first ball approaches nearby. You can't be sure of that. And here's Einstein in his autobiography, quote, Hume saw that certain concepts, as for example that of causality, cannot be deduced from the material experience and logical methods. In the reverse direction of science on the humanities and arts, Einstein's theory of space and time has had profound effects on the arts. The multimedia visual artist Athena Tachna creates sculptures that one experiences in a temporal way. And this is something that she wrote. It's not often that you get artists to write about their thinking and their process. Wonderful when they do. This is what she wrote, quote, time enters my sculpture at many levels, the very nature of space and matter, the interchangeability of matter and energy, the equivalence between acceleration and gravity, the interdependence of space and time, these and other such concepts from modern science greatly excite me, which I want to communicate through the language of form. In the 16th century, Copernicus' proposal that the sun is the center of the solar system, not the earth, has had vast consequences on how we view ourselves. When we realize that the earth is just one planet orbiting a star which is located on the edge of a galaxy with billions of stars in it, and there are billions of other galaxies in the observable universe, it's much harder to argue that the universe was made for our benefit when we understand that. Science, going in the other direction again, there's been an important role of metaphor, image, and language in science, not just as a pedagogical tool, but as an aid in discovery. In his little book, The Character of Physical Law, the great physicist Richard Feynman pointed out that there are several different ways we can visualize a scientific problem. If we're, for example, thinking of the Earth orbiting the sun, we can think of the Earth as responding to the distant sun 100 million years away, or we can think of the Earth as responding to the local gravitational field of the sun. These two pictures both lead to the same equations eventually, but they are very different psychologically, said Feynman, and very important in our different ways of finding new theories. I'll just end with a couple of more statements. It's always amazed me that we human beings are capable of both science and art, that we are both logical and illogical, deliberate and spontaneous, quantitative and qualitative, mechanical and intuitive. With our highly developed brains, with 100 billion neurons, each connected to 1,000 other neurons, we may be the most complicated object in the universe. Thank you.
Alan Lightman is hosting a new docuseries called Searching, Our Quest for Meaning in the Age of Science. It will broadcast on public television and begin streaming online at pbs.org on January 7th. Subscribe to Symposia wherever you get your podcasts, and if you enjoyed what you heard, share this episode. You can find more information about Brown College online at browncollege.virginia.edu.